Okay, so the reason we are doing this begin or bootstrap aggregation in full is because we want to reduce variance, right? So how much the final decision tree depends on the training data. But the problem is that, and this is what we saw, is that there could be just one very strong predictor that is going to be included into everything, and other predictors are not going to have a chance to be included. And because of this, the predictions are going to be highly, of different trees in the ensemble are going to be highly correlated. So which means that the variance is not really going to be reduced that much. And this is what happened in our data set, right? So if you look at all these first splits and all the second splits at all 98 trees in our backed ensemble, the first split is always the same, is the sex frequency, which is very, this is an extremely strong predictor. And the second split is in 98 out of 100 cases is age, right? So in 2 other cases is age when they met. So this is why they came up with this idea of kind of sacrificing accuracy of predictions, so which effectively means that they're going to introduce some bias to reduce the variance, right? And it is a very interesting idea, and it works. It works wonders. So then instead of allowing all the predictors to be variables at each split, so when we construct every tree, so we're going to pick those that are allowed to be used as predictors at random, right? So if we had 14 predictors or 13 predictors, if say just, I don't know, to construct every split, we just choose say 3 or 4 random ones, right? And this is what it's going to look like. So the first tree of this random forest uses sex frequency, the familiar predictor, as the first split, right? But then it just means that it was allowed to use sex frequency as a predictor just by random chance. If you look at the next tree, this is the next tree. So it does not have sex frequency as the first split or the second split. All right, so it has the income as the first split and age as the second split. So it means that, just by random chance, so when it picked predictors that would be used in the first split, just sex frequency did not appear there, and age did not appear there. So that's why they are not featured in the first split. And this is the third tree. I'm sorry, this is the third tree, and it uses age when met as the first split. And here, sex frequency does not even appear there. It means that just by pure chance, when we constructed these 3 splits for this tree, every time we picked a random subset of all the predictors, we just did not select the sex frequency, right? And this is how random forest works, right? So random forest is an ensemble of decision trees. Every one of them is trained on a bootstrap sample. But when they are trained, to construct every split, only a random subset of predictors is allowed to be used. And because of that, if you look at these plots, so then as the number of trees grows, we have plotted the out-of-bag error for random forest and out-of-bag error for begin, and same for test error. So you see that in the beginning, since random forest is constructed in a way where its accuracy is artificially kind of worsened, right? So we did not let these trees to grow optimally, so to make the best predictions as possible. So because of that, when the number of trees is small, the error of random forest, well, the out-of-bag error is not very good, right? So, and for a few trees, the out-of-bag error and the test error of random forest is worse than those for begin. But as the number of trees grows, then because variance is reduced. So I mean, we increase the bias a little bit, but reduce the variance probably by a lot. Because of that, typically when the number of trees grows, random forest is going to outperform Bayesian. And in this case, the accuracy of random forest, the test error of random forest is actually below, is around 12%, is even probably below 12%. So which is quite good. I mean, it's reasonably smaller than the error for the Bayesian. Okay, so this was random forest. So let's do a little quiz about random forest, about the random forest construction.